Hello guys, and welcome back to my channel Civil Construction and Tutor, and in this video I'll show you how to calculate the staircase load and apply it on the beam on which the staircase is supposed to rest instead of modeling the staircase. So in this video we'll be talking about two types of staircase, the very first being dogleg staircase and another being open well staircase. So the basic difference between them is that in the former one, that is the dogleg staircase, the load is distributed on two beams only, while in the open well staircase the load of the staircase is distributed in the four beams. So firstly we'll start with the dogleg staircase. So this is a simple plan of this staircase for a dogleg type. Here you can see this is the landing, this is the flight, and this is again the landing, and the dimension of is given as 1.273 for the first landing. Then we have flight of 1.5180, and then the landing, mid landing, which is about 1.931, and the width of the staircase is also 1.931. so this is the overall dimension of the staircase. Now if we see this in 3D view, so this is the first flight and this is the second flight, and the flight is supposed to rest on the mid landing beam and similarly floor beam, and the idea is that we have to calculate the load and distribute it on the beam on which the staircase is supposed to rest. So if we consider this first flight, then the general idea is that the half of the load of this flight, half of the load is distributed on this beam and half of the load is distributed on the floor beam. Similarly for the second flight, half of the load will be distributed on this beam and half of the load will be distributed in this beam. So in this way we have to calculate the staircase load, and in some cases you will see that the landing beam or the floor beam is provided just beneath where the landing starts, that is the beam is provided suppose over here. So in that case we will not compute that load considering as a staircase block, so we will just compute considering the flight and the mid landing. And in case if there is no landing beam provided, in some cases we will not provide landing beam, then we will just provide that load to the beam just beneath the landing slab. I will show you that while assigning the load in ETABS model. So the load that will be applied on the beam is simply dead load of the staircase, floor finish, and the live load acting on it. Dead load will be computed as the volume of concrete into unit weight of concrete, and similarly if there is brickwork, then we will compute the brickwork as a part of it and then apply with the unit weight of the brick masonry. But for now I am assuming that the whole structure is of concrete, and I'll just take the volume of the concrete and multiply it with the unit weight of concrete. I'll show you how to calculate that, and we will cross check with the volume given by AutoCAD as well. So I have made an Excel sheet for this. So unit weight of concrete, which is 25. Now let us take the riser. So here you can see the riser is of 0.148 meter, so 0.148. Similarly tread, so it is of 0.3036. Similarly width of staircase, as I have said, it is 1.9310 and 1.9310. Slab thickness, so it is of 0.15. okay, and step, that is simply using the Pythagoras theorem considering the riser and tread, so that is 0.34. Live load, let us assume as 3 kN per meter square considering residential building. Floor finish as 1 kN per meter square. Now type of staircase, as I've said, we'll be discussing about dogleg first. So dogleg staircase, length of first landing. So as you have said, the length is taken as 1.273 for the first landing, 1.273. Similarly, length of first flight 1.52. Number of steps in flight, that will be computed by using this formula, that is length of first flight divided by dimension of tread, then you will get the number of steps in first flight. So we have 1 2 3 4 5 number of flights, so that is computed. I have made a formula over here. Similarly inclination 30 degree, this is also from simple trigonometry. Inclined length, so this is a point that we have to understand. So if you see that was a plan length which is 1.5180, but we are considering an inclined section, so we have to consider the inclined length for computing the dead load of the structure. So it comes as 1.76. length of mid landing. So you can simply understand, I have just made a formula over here also, 1.52, which was the plan length, divided by cos 30.33, that is the angle. So this is 30.33, so this comes as 1.76 meter. Similarly, length of mid flight, that is mid landing, length of mid landing, which is 1.93 as well. Length of mid flight, so there is no mid flight as we are considering dogleg, so it will be 0. Now let us compute the volume of concrete, that is we are computing the dead load of the structure. So for the first flight, volume of concrete is equal to, we'll use the simple area of rectangle formula and then multiply it with the depth and we'll compute the volume. So volume of concrete is equal to 1.76 into 1.931. So basically this is the length of the inclined slab we have computed over here, into 1.931, that is the width of the slab. So inclined area, we have just computed the area of the inclined slab, we can say west slab, plus 1.273 into 1.931, that is the length area of the first landing. 1.27 is the length and 1.931 is the width, plus 1.93 into 1.93, that is the area of the mid landing. So 1.93 into 1.93 into, now as a whole, this is the bracket, into 0.15, that is the thickness. So we have computed the volume of the first flight. We have just computed this portion, we have neglected the steps, so we have to compute the volume of steps as well. So 0.5 area of triangle, 1 by 2 into b into h. So 0.5 into b being base, which is 0.148 into 0.306. So area of triangle 1 by 2 into b into h, and considering width, that is 1.931, so we'll get the volume 0.1 by 2 into b into h into length. So 1.931 into 5, we have 5 number of steps, so 1 2 3 4 5, so we compute considering 5 number of steps, so we'll get the overall volume now. So the overall volume of this portion is 1.65. Now if we compute for 2 number of flights, then the overall volume will be 3.3, that is multiply this value by 2. So now let us see whether it is correct or not. Mass property, this is from AutoCAD command, we can get the volume. So this comes as 3.37. So that is, we got 3.3, which is almost equal, or which is almost similar to that of the volume given by AutoCAD. What will be the total dead load? 1.65 into 25, that is volume into unit weight of concrete, then we'll get 41.25. Dead load per width, so this is a point load. Let me show you over here. So this is a point load. Now I have to distribute this on the beam. Then what I will do is, I will divide this point load by the width up to which the load has to be distributed. 41.25 divided by 1.931, that is the width of the staircase. So what we'll have is 21.36 kilonewton meter. So this is the dead load per width. We have to calculate the live load as well, that is live load per meter. The value we have entered is for per meter square, but for applying the load in beam we have to compute per meter. Live load per width, we have to understand this basic point. So for dividing the point load in kilonewton per meter, we'll divide the load or the point load by the width of the section on which the load is to be distributed. So we divided by 1.931, but for now we have an area load, and for area load to be converted into load per meter, then we have to multiply that particular area load by the length of the section. So 3 into 1.273 plus 1.76 plus 1.93. So 3 into length of the section, which comes as 14.89 kilonewton per meter. Floor finish 1 kilonewton per meter square. Now converting this per width, 1 into length of the section, and this comes as 4.96 kilonewton per meter. Now total load per width 21.36 with the dead load plus live load plus floor finish. So this comes as 41.21 kilonewton per meter. So this is the overall load for single flight. Now that has to be distributed on these two beams. So that means half of the load on this beam, half of the load on this beam. Hence load on each beam will be 41.212 divided by 2, that is 20.61. Okay, let me make you clear about it. So this is how the load is being distributed. 20.61 kilonewton per meter on this beam, 20.61 kilonewton meter across this beam. So don't get confused. The width of the section, if we compute as a point load, 20.61 into 1.93. So this is the point load acting on this beam, And for this beam the width is more, so 20.61 into 1.931 into 2, 20.61 into 1.931 into 2, because two number of flights are resting on this beam. So this will be the point load that will be acting on this particular beam. So this is how the staircase load is computed for dogleg staircase and applied on the beam. So now let us apply this load on ETABS model. So this is one of the staircase model that I had made for a building. Now let me delete all of this. So now we have to apply the load. Let us first calculate the staircase load. So this was for an example. Now let me calculate for a real case. So this is the plan of the staircase, and we'll take the dimension and apply the load. And remember, for this time we have a beam over here, so that means we'll not include the length of the or the weight of this landing. We'll just include the mid landing, and for which we have so this will be 25. The riser is provided as 150 mm, so that means 0.15 meter. Similarly, tread is provided as 0.25 meter. Width of the staircase is 1.520. Similarly, slab thickness is provided as 175 mm, 0.175, and you can compute this step as from the Pythagoras theorem. Live load 3 kN per meter square and floor finish as 1 kN per meter square. So this is a dogleg staircase, and length of first landing 0 meter, so as we are not considering the first landing. Similarly, length of the flight 2540, so 2.540 meter. Number of steps in the first flight 10 anyway, so this will be automatic value 1 2 3 4 5 6 7 8 9 10. So it is okay. Inclination 33 degree, so this is the inclined length. You can see I have just provided the formula, you can understand this. 3.04 meter. Length of mid landing 1.520, and the length of mid flight will be 0 as it is a dogleg staircase. Now the volume is computed as 1.50 meter cube. Total dead load computing 37.50, 24.67 will be the dead load per unit width. So you can see here I have just provided the formula as well, so you will not get confused. 37.50 divided by width of the staircase, 24.67. Live load 3 kN per meter square, 13.68, as we are considering the load with the across the length. So 0 as the length of the first landing, 3.04 inclined length of the flight, and this is the length of the mid landing. So floor finish, so total load is 21.46 kilonewton meter. And in previous video where I discuss about the ETABS modeling and analysis of residential building, that we can take as the staircase load 22 kilonewton per meter, 22 kilonewton per meter. So that was the idea behind that value. So generally for residential building, the load from the staircase is about 22 kilonewton per meter. So now this load is to be distributed in this manner. So 21.46 on this beam, 21.46 in the mid landing beam, and 21.46 on this beam. But remember, we are not considering the length of landing, so the beam is supposed to be provided by the time when the landing starts over here. So let us go to the ETABS file now. 21.46, so this is the mid landing, so here we have to apply 21.46. Similarly here also 21.46. Assign, go to frame load, distributed load, and you can separate it as a stairs dead or stairs live. So I'm just computing as a overall value, so I'll just provide stairs dead including the live load as well. But in general practice you can assign stairs dead load and stairs live load separately. So 21.46 kilonewton per meter. Apply. So this is how the staircase load is applied on the mid landing beam. Similarly in this case, two number of flights will be resting, so 21.46 here. So now we have to apply load for this beam, as we have done 21.46 for beam where two number of flights rest. But for this beam, a single flight will rest on it. Hence we have to make sure that the staircase loading is different than that of this beam. And for now, if we want to distribute this load throughout the beam, what we can do is 21.46 divided by 2. Why? Because that was for two number of flight, but for now we are doing for a single flight, hence we have to do 10.73. that is half of the staircase load that we provided for a beam on which two number of flights were resting. If we want to apply 21.46, then the case will be different, because we have to assume the width of the staircase only, and for which it will be a different case, and that is a good practice, because the staircase load is to be assumed to be concentrated throughout the width of the staircase only. It is not distributed in this way, so we have to consider 21.46 acting along the width of the staircase only. So 21.46, but the idea is different to apply this load. We have to use this trapezoidal load concept. So 0 load will be 21.46. Make sure to select absolute distance from end I. So remember, it will apply the load considering end I, and for this beam, so this is the end I, but the load is to be applied from this point. Let us see the width of the section, 3.581, and similarly it will be 3.581 minus 1.52. apply. So 3.581 minus 1.520 will give me this point. So if you have modeled the plinth beam as well, then you have to consider the staircase load on that beam as well. Replicate this. So we know that the plinth beam will be just below this, and we'll replicate this particular beam. So story base, apply. So we got the staircase beam, that is the plinth beam at the base level as well, and the loading will be different because only single flight will be resting on this particular plinth beam. So the basic idea point end I and end J is that if we the point from which the beam is being drawn is known as end I. That is, I draw the beam from this point to this point, so that is end I will be this point. Okay, now we have to apply load from this point to up to the width of the staircase, so 1.52 meter from this point. And for now, end point 1 will be at 0 distance from end I. Similarly, end 2 will be at distance 1.52 meter. So 21.46 will be the load that will be applied throughout this width of the staircase. So apply. Now you can visualize the staircase loading. 21.46, that is for single flight. At the mid landing level, we have two staircase flight resting, so 21.46 throughout the beam. Similarly, 21.46 in this particular beam, 21.46 on this beam, and as the single flight will be resting on the top story and the loading will be provided on the beam. Now let us go for the open well staircase. So this is a general model for a staircase of open well type. So you can see here the loading. So for the first flight, the loading is done half on this particular beam, similarly on this beam, and for this flight the loading is done on this beam and on this beam, and for third flight the loading is done on this beam and on this beam. The difference is that according to IS code 456, so if we assume that the load of flight being W, then the load of landing is taken as W by 2. That is, half of the load of this landing is distributed on this beam, and half of the loading of the landing is done on this beam. Similarly, for this landing, half will be distributed on this and half will be distributed on this. So that is the idea. You can see here W by 2, and similarly for this flight, W by 2, W and W by 2. So to make it easy, I have distinguished the color as well. So for this landing, as I said, half load of the landing is distributed on this beam and half will be distributed on this beam. Similarly, for this landing, half will be distributed on this floor beam and half of the landing load will be distributed on this beam. So the load is being distributed perpendicular to the span of the staircase. Now let us calculate the load. So I made a separate sheet for that as well. The dimension is kept same. So 25, riser is 0.148, 0.306, and similar width of the staircase is 1.93, and slab thickness is 0.15, step 0.34, that is slab load is taken as 3 kN per meter square, 1 kN per meter square. Type of staircase open well. So that means we will consider the load of both the flights. So length of first landing 1.27, 1.52 as the length of the first flight. Number of steps 5 numbers. Inclination 30 degree. Inclined length as we have just computed 1.76. Length of mid landing 1.93. Length of mid flight as 1.52 meter, that we had excluded in the previous type in the dogleg. So it was 0, for now it is 1.52 meter. You can see from here as well. and number of flight will be same, that is 5 numbers, 30 degree 1.76. Now for first flight volume of concrete, so this is the point that we have to understand. 1.76 into 1.93, that is the uh, area of the inclined slab. 1.76 is the inclined length, 1.93 is the width of the section, plus 1.273 into 1.93. So for first landing there is no any issues, we'll consider the whole length. So 1.273 into 1.93 plus 1.93, that is the width of the stair here, landing here, into 1.93 divided by 2, that is half of the staircase landing, that is the mid landing. So 1.93 divided by 2, we are considering the half dimension only, into 0.15, that is thickness. So we got the volume of the slab of the staircase. Now considering the steps, 0.5, that is 1/2 into b into area of the triangle into width, that will give the volume into number of steps. So we get 1.37 meter cube. So the basic difference between open well and dogleg staircase is that we'll consider half of the landing load for each flight. So total dead load 1.37 into unit weight 34.25, dead load per width 17.75. we are dividing the point load now into the uniformly distributed load, so we get 17.75 kilonewton per meter. Live load 3 kilonewton per meter square. Live load per width 1.273 plus 1.76 plus 1.93 divided by 2. We'll consider half of the load on this particular section. So the length is also taken half of the total length. Similarly floor finish, and we'll get total load per width as 33.74 kilonewton per meter, and load on each beam is 16.87 kilonewton per meter. Now this load is distributed 16.87 per kilonewton meter on this particular edge, 16.87 kilonewton per on this particular edge, 16.87 per kilonewton per meter on this edge. So this will be the difference. Similarly for the mid flight, 1.76 into 1.93, that is the area of the inclined flight, plus 1.93 divided by 2 into 1.93, half of this landing. Similarly half of this inclined landing, half of this landing, into 0.15, we will get the area volume of the staircase slab, plus for the steps as usual area of triangle into width into number of steps. So we'll get 1.28 meter cube. Now total dead load. Now let us check the total volume. 1.28 plus into 2, so this is 4.02. now let us go to this and mass property 4.06, so this is almost equal. So the volume calculation is okay. Total dead load you can understand now, 1.28 into 25. Total dead load per width of the staircase 1.93, so we get 16.58. so the load on each beam will be 15.67 kilonewton meter. And remember live load per unit width 1.93 divided by 2, half of this, plus flight half of this. So in this way you can compute the total load 15.67. so now the difference is that 16.87 in this flight, and for the mid flight we have 15.67. now let us apply this load and we'll consider our new case. Okay, let's take the dimension, and there is a beam over here, so we'll not take the landing portion. Trade is 0.15, 0.25, 1.02, slab thickness 0.15, open well, length of landing 0, 1.0, 1.02, and the width is 1.27, length of mid landing 1.27, length of mid flight 1.02. so volume of concrete will get all of this term. I hope you can understand this value, 0.46, 0.46, 0.58 for the mid landing. So the total load is 8.36, 8.36, 10.81, 10.81, 8.36, 8.36. as we don't have a landing over here, so the load is coming less. Now let us apply this load. So this is our model. So you can see here how the staircase is supposed to rest. As we don't have a mid landing beam here, so the load will be applied on the plinth beam over here. Similarly for this staircase, the load is applied on this beam, and the load of the mid flight is applied on this beam and on this beam. Now let us apply the load. So for these two and this, we'll apply 8.36. That is the load of the first flight and third flight. But the point I and point J may be different, so we'll do separately. Assign, go to frame load, distributed, steer dead. As I said, you can apply steer dead and steer live separately, so that is up to you. The coordinate is 12.575, 5.28, so which is the end I, so end J. So this is end J because it was 12.75 and 5.28, and the length is 3.683. So the staircase is starting from this point, so we'll have over here. Okay, let us draw plinth beam as well. Replicate. Okay, we'll start from this point. So the staircase starts from this point, and this is end J. So what is the dimension? 3.683. Absolute distance from end I, this will be 3.683, and this will be 3.683 minus width of the staircase 1.27. I hope you have already understood this point. And the load is 8.36. Apply. So this is the first flight from the plinth beam. Now let us go to this beam. So in this beam, two number of flight will rest, and at this point and at this point, that is not throughout the beam. So for this beam also apply, and in this beam we'll have only single flight that will rest on this particular point, and on this beam it will have, because there is no mid landing level, so the staircase load will applied on this beam through the wall which is provided over here. Now for this and this and this as well, what we can do is 0, 1.27 and apply. We have to do add to existing load. So this is for the main flight, that is first flight and the third flight. Now for mid flight, the load will be acting on this beam, and let us find out the end I and end J. So this is end J, and what is the length? 3.683. so 3.683 minus 1.27, 3.863. And what was the load? 10.81, 10.81, 10.81. Apply. Similarly, it will also have 10.81. There won't be any load up to this point. Now for this as well, we have to find the end J. So it says the same thing. Go to this as well. Now apply. And if there is a plinth beam, obviously there will be, replicate that and story, apply. So this is how the staircase load is applied. First flight, and then from the mid landing we have load on this beam, as there is no any mid landing beam, 8.36, 8.36. Similarly in this particular beam, as there is mid landing, so the load will be applied on this beam as well. So let me unhide the object. So you can understand now. Okay, the load of this flight is acting on this beam, the load of half of the load is acting on this beam, half of the load is acting on this beam and on this beam, and as there is no any furthermore, so only single flight load is acting on this beam, and that is up to for 1.02 1.27 meter, that is the width of this staircase. So in this way the load is applied, and you can check for the staircase loading, and you can finally analyze the building. So I hope this video helped, and if it did help, do like and subscribe, and let me know in the comment section if you have any queries. And thank you Avinash Nivanidai.